Hi all. And the last video we mentioned about that we are going to take a lecture series on drilling engineering based on this book. And we also gave some overall idea about the content of this book, like introductions and what is the main drilling techniques that using today, like rotary drilling. But mostly in this lecture series, we will be focusing upon chapter 4, namely drilling hydraulics, like what are the types of fluid flow, what is laminar flow, turbulent flow, flow through pipe, flow through annulus, what is the empirical formula to calculate pressure drop across the pit, and so many other things. So main focus about this lecture series will be upon the drilling hydraulics, like chapter 4, and also chapter 7, like drilling fluid, what are the types of drilling fluid, and how do we calculate the mud based on the geomechanical properties of the drilling site. And chapter 8 and chapter 9 will be giving some overall idea, and we'll also have some thorough idea and thorough introductions to what are the borehole problems, like stuck pipe, loss circulations, blowout, and what are the types of cakes, how to prevent those borehole problems. Cementing will be given some overall idea. So now let's come to the chapter 1. So what this book says about chapter 1 is it gives that the objective is to do successfully drill and make a hole. Yes, the fundamental purpose of drilling is to make a hole to extract the oil. And with respect to making a hole, we keep in mind two goals. One is to drill and make a hole in a safe manner. Personal injuries, to avoid personal injuries, and also to avoid technical problems. The second goal would be to successfully complete this drilling with a minimal cost. There are different technologies to make a hole have been applied so far, but the most successful and the most used technology for drilling a hole for oil and gas purposes rotary drilling. So we will be more focusing upon the rotary drilling on the chapter 2. So we will give some overall terminology that used in drilling engineering, like who are all the persons involved in, like tool pusher, company man, driller, derrick man, floor man, mud engineer, and mud logger. And section 1.4 says that based on the well depth, the wells are classified into shallow well, conventional well, deep well, ultra deep well. So, but based on these advanced technologies utilized now, like mud while drilling and log while drilling, we could able to achieve that we can able to make a drilling more than 10,000 meter possibly today. So chapter 2 is about rotary drilling rig, which is most common drilling technology used nowadays. So here the technology is to create a rotation in the drill strings. So based on the rotation of the drill string with the drill bit at the bottom, we could be able to make advancement in the drill string so that the holes are drilled. This is a chapter, this is a figure 2.1, says about the overall idea of the rotary drilling. So it has some various systems like power systems, circulation systems, pressure control systems, hoisting systems, rotary systems, and derricks and other substructures to conduct drilling and make a hole to extract the oil from the bottom porous media. So again, the rotary rigs can be further distinguished based upon where the site is, land rigs and offshore rigs. Sorry about that. So I told you that there are different systems. One is the power system. Power system, like name implies, it is purpose is to supply power to various other components, especially rotary system and the circulation systems. Also secondary components like blowout preventer and water pumps and lighting systems. And the hoisting system, the purpose is to lower and raise the drill strings, casings, and other surface equipments into and out of the well. So these are the components involved in the hoisting systems, which we will not go deep into that. As I mentioned earlier, we will more concerned about the mud hydraulics and circulation systems. So it also helps to make a connection. The make a connection means the periodic process of adding a new joint of drill pipe to the drill strings. Also hole deepens is referred. And also while making a trip. The trip is the process of moving the drill string out of the hole for the purpose of changing the drill bit. The drill bit can be worn out because of uh, so many pressures for cutting out the rocks, and also to change the drill strings and again start the process. So tripping is about like temporarily stopping that drilling operations and change the necessary worn out equipments and put back into the operations. So wiper trip is not necessary to take out the drill string completely out of the hole. It's just to lift the drill string out of that bottom hole and to clean the hole from the remaining cuttings that may have settled along with the open hole sections. So now we will go to the circulation system. The circulation. This is the overall nice picture about the circulation systems. It starts with the mud pump. It starts with mud house. Muds are prepared, and it starts with mud pit where the necessary all the components are added to fulfill the requirements of certain mud properties. And once this is a suction pipe and this is a mud pump, and through the suction pipe the mud is drawn from the mud pit and it is pushed uh, across various pipes to the drill strings. The various pipes involves standpipe, rotary hose, and other rotating pipes. So once it reaches the drill pipe, it passes through various components of the drill strings and it comes out of the drill bit. And once it comes through the drill bit, it flows out through the nozzles. And the purpose of the nozzles is to create a high jet velocity so that all the additional cuttings settled at the bottoms can be transported up through the handlers. And once it mud takes the cuttings along with it and flow through the handlers, it comes out through the shale shaker and settles down. And all the other once those cuttings are being settles down, it returns to the mud pit. So this is mud circulation systems, and that's what it described in this paragraph. So the main purpose is to maintain the geomechanical properties while the hole is being drilled, and also to remove the cuttings settled at the bottom. And once the circulation is completed and the mud is returned to the mud pit. So this is what overall picture about the mud circulation systems. So mud pit, suction line, mud pump, different discharge pipes, which include standpipe, rotary hose, and it flows through the drill string. Drill string has drill pipe, drill collar, and once it comes through the nozzle of the drill bit, it flows through the annulus carrying the cuttings cut by the drill bit, and it returns to the shale shaker where the unnecessary particles are being removed. Then once those mud is clean, it returns back to the mud pit. This is about the circulation systems. And one of the main component involved is mud pump. The mud pump can be a duplex mud pump or triplex mud pump. Duplex mud pump, as mentioned in the name, it has two cylinders and it's double acting and forward movement of the barrel. So these are the volumetric uh, volume displacement calculated based upon the geometrical properties of the cylinder, the diameter and the length. And the backstroke has additionally it has like kind of a piston that area has to be that volume has to be subtracted. So the overall volumetric displacement would be this 2.26, and efficiency, volumetric efficiency is multiplied here. And triplex mud pump will only a single acting, so it is the overall volumetric displacement added with the volumetric efficiency in 2.28. And once it is for a single push for a number of cycles per unit time. This will be the NNTF is the volumetric flow rate, and N is the number of cycles per minute. And this is the power required. This since the inlet pressure is always atmospheric pressure, the discharge pressure will be the mud pump pressure, and this is the difference in pressure, and the flow rate will give you the hydraulic power of that particular pump. And additional equipments are the surge chambers, because when the mud is it's a reciprocating displacement pump, so it has some certain kind of pressure pulses that has to be dampened out. That purpose is being done by these surge chambers at the and also there should be a pressure relief valve for a safety purpose in case for accidentally a human error discharge valve is closed, that other expensive equipment should not be blown out. So for that a relief valve is set at the discharge line always. And the shell shaker is consisting of vibrating screens, mud pits. The main purpose of the mud is to hold that excess mud, and also it supplies the mud when there is a problem like borehole problem like loss circulation, which we'll be discussing about the later part of this chapter. So this is all about the circulation system, the rotary system, and other things we will be possibly discussing in the next lecture. Thank you.